this video will cover section, well, it does not have a number, but it is properties of logarithms. So we're going to cover the product property, then quotient property, and finally the power property. So with the product property, we could go from left to right, and we refer to that process as expanding or expand something. We could also go from right to left, and we will refer to that as condensing. So the instructions might say condense. Now what I want you to write down is that right here, the left side is called the log of a product. And it is a product because the x and the y are multiplying each other, right? Now the right side, it is going to be called the sum, because you're adding the sum of two logarithms. All right, now before we start applying the rule, which we're going to do on the next slide, and it's very simple, I'm going to show you guys the proof. And this might be the first proof you have ever seen. It's not a formal proof. I'm going to call it a baby proof. And so it's just to show you why is this formula true, okay? So if you don't understand it, that is okay. All right? I just want to start introducing you to it because you're going to do proofs in geometry, and you will also see them in pre-calc. So we start by what is given to us, and just so you know, you're going to do the one on slide 3. So I'm going to prove the product property, and then you are going to prove the quotient property, okay? All right. So we start by making an assumption or letting something be something, and so that will be here. Let the log of x base b equal m, and the log of y base b equal n. So I'm just going to rewrite them here. All right. After that, we're going to convert to exponential notation. So my first term, or my first equation right here, if I convert that to exponential, it's going to, remember, we take the base, b, to what power? Right here. To the power x or to the power m? Power m. We switch this to, so the x is no longer with a b. Okay, so let's try the next one. So we take this expression, convert it to exponential. So of course, first we take the base to the power n, and that will equal y. Okay. Now, what we're going to do, since we're trying to prove the product rule, let's kind of like refresh our mind with what happens when you are multiplying two letters. That are the same. What do you do with the exponents? You add them. Very good. And so that's what I'm going to write down here. So b to the power m times b to the power n is equal to b to the power m plus n, right? You guys are comfortable with that? Okay. So since that is true, then we're going to substitute here. So I'm going to put it in parentheses. B to the power m with x. and we're going to substitute b to the power n with y. Right? So right here, b to the power n is going to be x, and b to the power n is going to be y. Yeah? All right. So this becomes x, and this becomes y. Okay, now we are going to change it back to a logarithmic expression. So I want to give you guys a few seconds to try to change it on your own. Keep this together and this also together. Okay? So remember, the first step is to write log. Then you take the base. Just give it a try. If you get it wrong, it's fine. All you gotta do is correct it. So what should I have next to the word log? xy or n plus n? xy. So that is the argument. That's how we refer to that quantity. And on the right side, we will just have m plus n. All right. Now, I want you to look at the board to the stuff I highlighted, or I circle with the highlighter. And think about something that you could replace capital M and capital N with. Thank you, Matthew. So, instead of M, I'm going to use this. And instead of N, I'm going to use this log. Okay? And of course, I told you this is an informal proof. So if you notice, we arrived to what we were trying to prove, right? We already got the left side looking like the right side. In a formal class, in a formal proof, you will have to prove it both ways, like going from left to right and right to left. Okay, that's why I call this one a baby proof. Now, if you don't understand it, it's okay, because it might be the first time you have ever seen a proof, right? But I bet you that when you see it again in pre-calc, you're going to remember it. You're going to be like, oh, I remember this. Okay, so now applying the formula is a lot easier. So let's try that. So part A here. Now, one condition to be able to use the product property is that the base has to be the same. So here we have base 11, base 3, base 3, base 2, base 2. So let's see, for my first one, it will be log base 11. And since we have here the sum of two logs, we can condense them. That's what it means to write as a single logarithm. Condense. So we could condense them as the log of a product. 3 times 10, and yes, of course, we multiply it. So that will be the log base 11 of 30. The next one, we check they have the same base. They are adding. We have the sum of two logs. So we're going to condense them by multiplying the two arguments. So 1/2 times 12. And remember that when we multiply fractions, we have to multiply straight across. So 1 times 12 is 12, and 2 times 1 is 6. And of course, if you can reduce it, you will. So that will be the log base 3 of 2. Wait, something wrong.
It's 1/2 times 12.
You know, I do that a lot. I actually did it in one of my anatomy exams. I kind of do the operation in my head. So it's a 2, and then this was a 6.
Okay,
right?
Like,
yes.
Yes.
That's what I was saying. I put a 6 because I was already dividing. No kidding, I did that in an anatomy exam.
Did you fail?
No, I didn't fail. I just got that question wrong. And it was crazy because I did all this crazy proof about it, and then like the final answer was wrong. Okay, next one. So again, we have the sum of two logs, right? They're adding. So we can condense them into the log of a product. And right here, I'm just going to use brackets, but you could just use parentheses again. Correct. So then we distribute, so we're going to multiply, and that will give me x squared plus 2x. Now, do you guys think that is right?
Yes. No.
There's something wrong about it. Very wrong.
It's like, it looks like there's an exponent to the exponent.
You can have an,
Well, this one is not an
Yeah.
exponent.
But
you can have an exponent.
No, I can.
you have two terms.
Well, it kind of comes from the fact that there are two terms. What do you say, Julio? No parentheses. That's right. What this means is that you're only taking the log of x squared. But that's not true. We're taking the log of this whole thing. What was it? Plus 2x. So you must, in your argument, please write it down. If the argument contains more than one term, you must use parentheses. In pre-cal, I take a lot of points off or little things like that. Just so you know. Super picky when I grade those exams. All right, so now I want you guys to try the next three on your own. They're pretty easy. They're exactly, very similar. Not exactly the same, but very similar to the other three. And if you need assistance, let me know. Raise your hand.
So everything always has to be simplified?
Yes, we will simplify it again. So here are the answers for the practice problems. Okay, now let's go to the next rule. So we have the quotient property of logarithms, and you already know that that implies division, right? So we're going to go from division to subtraction. So this is called the log of a quotient, which is like a ratio. And then on the right side, we have the difference, because they are subtracting each other.
Oh, subtracting.
Yeah, the difference of two logs. And so we're going to start, I'm going to get you guys started, and then I want you to work on your own. So we're going to start by letting log of x base b equal capital M, and log base b of y equal capital N. And then I'm just going to write something here quickly for you. When you do something such as b to the power m divided by b to the power n, what do you do with the exponents? Okay, so that will be m minus n. So you're going to have to use this fact, okay? So I'm going to pause the video and then we'll check. You can work with a partner if you want to. So we just finished the proof of the quotient property of logarithms. And we started by letting log of x equal m, log of y equal n. After that, we converted to exponentials. And then using the rule with exponents that states that if you divide two letters, you must subtract their exponents. So we used that, and then we used the fact that x is equal to b to the power m, so we substituted that x here. And then y is equal to b to the power m, so we substitute y over here. And after that, we replaced, we converted to log. So we got log base b of x over y equals n minus n. And then finally, we substituted m and end with what we had from the beginning, right here. And we are done with that proof. So now let's go ahead and apply it, and then we'll take a break after that. So let's do this first three, and then we'll go take a break, and when we come back, you guys will do the next three. Okay. So now you notice it says write as a single logarithm. So again, we are condensing, right? So we're going to condense. So right here for part A, we're going to have log 10 base 10 of 27 over 3. And of course we could divide, right? So that would be 9. And here we will have 8 over x. Now I want to ask you guys a question. If problem B was stated this way, should I still write the 8 on the numerator or the denominator? What do you guys think? It's a tricky question. So actually the answer will be the same. And so what we go by is not what term is first, but what term has a negative sign in front of it when it's a log. So whatever is preceded by a negative sign is going to have to be, the argument for that log will have to be denominator. All right? And whatever has a positive sign, like right here, even though it's the second term, the argument goes here. All right? So if I try to trick you, you know that. If it has a negative, it's part of the bottom. All right, let's take a break, and then when we come back, you guys do that. We did skip the part C, so let's go ahead and take care of that. So that will be log of base 3 of the quotient x squared plus 5 over x squared plus 1, right? And then we're going to simplify, so we cross the x squares, right?
Yep.
No.
No?
This is not. Because they're terms, not factors. If you had something like 5x squared and then 1x squared, then yes, you can cancel the x squared.
Oh,
But in this case, you cannot because they're terms. How do we know they're terms? Because there is a big plus in
so would
between.
it be just 1?
So the correct answer is this. And that's it. You do not simplify it, okay? So now please go ahead and complete the next three. So here are the answers for the quotient property, the last three problems, the ones that I wanted you to try on your own. So let's go to the next and last property. And that one is the one that you can see on that green poster at the end. And it is called the power property of logarithm. And the term power, it comes from the exponent here. Do you guys see it? That tiny, tiny little r. So what we do is we're going to take that to the front. And what happens, I want you to write this with words. The exponent of the argument becomes the coefficient of the logarithm. Just like you see it here. What do you guys think the r and the expression log of x base b are doing to each other? Multiplying, because there's no sign in between. Okay, so that's why we can call it the coefficient. So this is very easy to use. You look at the exponent and you just take it to the front. That's it. That's it. There's a proof of that one. It's a beautiful proof, but it's pretty lengthy. And so I'm going to save that for your freak out. class.
Yay.
And that's it. That's all you do. Now, for part B, first we need to change the square root into an exponent. So that will be, what will be the exponent of the square root? 1/2. And so that will be 1/2 goes to the front times the log of 2 base 4. Remember, this is like a coefficient, so yeah, it is bigger. It gets bigger. Someone asked me that earlier. So the next two are for you to do. And part B, please notice that we're talking about a fourth root, not a square root, a fourth root, okay? So the exponent is going to be a little different. It's not going to be 1/2. That's what I'm trying to say.
1/4?
Perhaps. Yes, it is 1/4. Okay, so I'm going to start writing my answer. So you can check yours. 8 times the log of x base 7. Right here, this is the same as the log of 7 base 5 to the power 1/4. So it becomes 1/4 log base 4. Yeah? Do we all agree? Okay. Now, you guys ready for your graduation of logs? Yes? Okay, of logarithmic properties? Okay. So, before I forget, I'm going to throw an extra term here. You want to start? Yes. So, part A, we're going to use the power property, and we're also going to use which one, since we have the sum of two logs? The product property or the quotient property? Product and power, right? So you could use the power property in reverse as well. So you could take this one, and then goes from being the coefficient to being the exponent of the argument again. And if you notice the instructions, it says write as a single logarithm. So what that means is that we're still condensing, right? So this will be log base 5 of 3 squared plus log base 5 of 2 to the third power. Now from there, it's your choice in which order you take the following steps. Now at the end, since we have the sum of two logs, what's going to happen when we condense is that we will have the log of a product. So 9 times 8, which is 72. So first I use power rule, so that's why I have 3 squared to the third power, which is this one over here. From there I got 9 from here, 3 squared. Then I got 8 from 2 to the third power. Remember, that's 2 times 2 times 2. And then I multiply 9 and 8. That's what I did here. And I get 72. That's right, correct? Yeah? 72? Okay. What am I asking? All right, B. So we're going to apply the power rule again. In reverse. Power property. So log of x cubed base 9 minus the log of x plus 1 base 9. And so when we condense them, are we going to have the log of a product or the log of a quotient? Yes. Okay. Why? Because it's subtract. Right, and then the last one, you guys notice how we do have two terms that have a positive sign in front of them, right? That's one, and the other one, it will be the first one. And we also have two that have a negative sign. Now, we could do this a very long way, and I can explain you why. Or I could just tell you that whatever has a positive sign is going to be part of the numerator on top. And whatever that has a negative sign with the log expression, those arguments will be on the bottom. Like that. That's like the easiest way to do it. And then of course we simplify, so this will be the log base 4 of 75 divided by 5x. And finally we'll get log of 15 over. And let's not forget the base. All right, now you guys are going to do the next three. Let me add an extra term here for you.
Yes.
I was being mean to you guys. Just like so here are the answers for the last three problems of that slide. We have the log base 5 of 512, log base 8 of that expression, and log base 7 of that one. Now the good news is that we only have a couple of slides left. Let me tell you why. This very last one you don't have. However, at the end of the class, I'll let you take a picture with your phone because it's kind of nice to have them handy. These are the rules we covered today. And the other three, we covered them last week. Okay? Now, this slide, number 8, you don't have it because it just happens to be the same problem as that. So in reality, we just have 2 slides to go. And yes, we will finish. Now, what we're doing here is the opposite of condensing, which is actually expanding or expansion, yes. So we're going to expand. And so it says, write the expression as sums or differences of multiple logarithms. So right here, this first problem, part A, the 5 and the 7 are in the numerator. So when I expand them, that means that those are positive logarithmic expressions. Like that.
Oh, so it's just the opposite.
Correct. And then here, I will have a minus because 4 is down here in the denominator.
Okay.
Now the next problem is going to have x to the 5th minus the log of y squared base 2. And here we could use the power property.
Oh, okay, I did that. That was wrong.
Now, sometimes it's more convenient to leave them this way, and others this way. So you will notice that when we start using them for to solve equations. 2. So if you guys could please do the next 2. So those are answers for those 2 questions. And let me just ask you quickly, someone asked me that earlier. What if you have something that is written this way? How would you do that?
there'll be 1 over x to the power of 1 minus
So you're saying 1 over x.
1 over y to the power of 1.
Like that? Well, it is like that. If you think about what I told you, if they have a negative sign, isn't it true that I told you they both go on the bottom?
Oh yeah.
But yeah, I like that Matthew told me 1 over, because that was going to be my question. So what do we put on the top? And yes, it is here. What do we put on the top? And
Oh,
so
wow.
we have to put something on top. That something is 1. But that 1 is not appearing there by magic. That 1 actually comes from here. What's the log of 1 of any base? What is this equal to? It's on the bar, right? It's equal to 0. So in reality, with this, we're not really changing the expression. We're just kind of like helping ourselves because we needed this 1 here.
What happens when we have different bases?
You cannot use the property. Good question. So they must have the same base. Yeah.
So we won't get questions that are different bases.
And I might to trick you.
And then what do we put?
Then you say you put the same thing. Nothing can be done.
Couldn't you do that? Would it be 1?
No. But I'll tell you why in a minute. All right, let's finish this one. So right here, what we're going to use is 0.43 or 0.68. And what those two numbers are representing is the log of 2 base b and the log of 3 base b, okay? So I want you to look at the two arguments that we have here. The argument is a big number, the big 2 and the big 3. How can we make a 6 by using a 2 and a 3?
2 times 3.
Okay, so multiply. So we will say the log of base b of 6 is the same as the log base b of 3 times 2, correct? Yes? And if we apply the product property to expand, it's going to be the sum of 2 logs, right? That's what we did. And here, if you look at it, the log of 2 has a value, it's 0.43. So that's what I'm going to put here. And the log of 2, oh, I have them backwards. The log of 3, this should be first, is 0.68. And the log of 2 is 0.43. And if we add those two numbers, we get 1.11. Now, part B. Our new argument is 9. How can we make a 9?
3 squared.
3 times 3 or 3 squared, right? So I want to use 3 squared. It would be the same thing, but I want my example to look a little different. So what I do here is I move the 2 to the front by using the power property. So that will be 2 times the log base 3. I'm sorry, log base b of 3. And so we do have a number that is equivalent to that, right? It's 0.68 right here. So that will be 2 times 0.68. And that will give me 1.36. Left. And now the very last one, we have a square root. Well, before I do the last one, are you guys confused?
No.
Because other classes, some students were.
No.
Are you guys realizing what I'm doing? So what I'm doing is taking the values from here and substituting them here, right? So right here, the 0.68 is replacing that, and then the 0.43 is replacing this one here. Okay, so let me do the last one, and the log base b of the square root of 2, I'm going to call it the log of 2 to the 1/2. From here, I can apply the power property, so it will be 1/2 times the log of 2 base b. So this will be 1/2, and then what should I replace the log of 2 with? 0.43. Remember, it's coming from here. So that will be, this is like dividing point for 3 by 2. So it's 0.215. Okay. All right, so do you guys have a question? No? Okay, so I'm going to let you guys go.